Have you ever wondered what happens way, way above a massive thunderstorm? Far beyond the lightning we can see, up in the thin air, right near the edge of space? Well, it turns out our planet puts on a secret, absolutely spectacular light show up there. It's a phenomenon that's baffled people for centuries, and we're about to dive in and see exactly why. So that was the reaction of a citizen scientist named Paul Smith. It was the very first time he managed to actually capture one of these phantom lights. He was out trying to photograph a meteor shower, and on a total hunch, he pointed his camera at a distant storm, and he caught something truly unbelievable. And this is what he saw. A massive, blood-red, jellyfish-looking thing that just flickered into existence for a split second. Now, these aren't UFOs or some kind of weird legend. They have a proper scientific name: transient luminous events, or TLEs for short. For the longest time, pilots would tell these stories about strange lights dancing way above the storms, but, with no real proof, they were often just dismissed. It actually wasn't until 1989 that scientists completely by accident caught one on video while they were testing a camera, and that's when they finally proved these phantoms were real. Okay, think of this diagram as our roadmap for this explainer. We're going to take a journey straight up, starting from the top of a thundercloud, moving through all the different layers of the atmosphere to meet the entire bizarre family of TLEs. So here's the most important thing to get your head around. All of these incredible phenomena are powered by the same engine, a massive thunderstorm happening way down below. The storm's insane electrical energy doesn't just shoot down as lightning. It also projects a huge electric field way, way up into the atmosphere. All right, our journey begins right on top of the storm clouds, up in the stratosphere. This is where we find our first category of TLEs, and honestly, they look pretty much like lightning in reverse. These are called blue jets, and unlike the lightning you're used to, these cone-shaped blasts of energy shoot upward from the cloud tops, reaching high into the stratosphere. And here you can really see their distinct personality. They're way brighter than other TLEs, and that signature blue color? That comes from electricity getting the nitrogen molecules in the stratosphere all excited. And then you've got the real overachievers. A typical blue jet might reach, say, 40 kilometers up, but the most powerful ones, which have the perfect name, gigantic jets, can reach an unbelievable 80 kilometers in altitude. They literally bridge the gap from the storm cloud all the way up to the ionosphere. Okay, let's climb even higher, up into the mesosphere. This is where we meet the most famous and, honestly, the most visually stunning TLEs of them all. These are sprites, and while they can be enormous, we're talking 50 kilometers tall sometimes, they're actually very weak, super dim flashes. And here's the key difference. They don't actually come from the cloud itself. They're more like an electrical echo in the sky, triggered by a really powerful lightning strike miles below. And this picture just nails why they get those weird comparisons, right? You can totally see the complicated branching tendrils hanging down just like a jellyfish. That reddish color comes from nitrogen getting excited in the much, much thinner air of the mesosphere. So how exactly is a sprite born? Well, it all kicks off with a very specific event, a powerful, positive cloud-to-ground lightning strike. That positive part is absolutely crucial. When that positive charge is suddenly ripped out of the cloud, it creates this massive, momentary electrical imbalance way up high in the mesosphere. That field is just strong enough to cause an electrical breakdown in the thin air, making the nitrogen molecules glow that signature red, and poof, a sprite appears for just a few milliseconds. For our final ascent, we are going all the way up to the highest altitudes, up to 100 kilometers, right to the doorstep of space itself. And as you can probably guess, this is where the TLEs get even stranger and even bigger. Up here, we find ELVES. And yeah, it's an acronym for a super long name, but what you really need to know is that they are these rapidly expanding rings of light. But unlike sprites, they're not a direct electrical discharge. No, these are triggered by the electromagnetic pulse, the EMP, that radiates out from a big lightning strike. The scale here is just staggering. That EMP expands outward like a sphere, and when it smacks into the ionosphere at about 100 kilometers up, it energizes nitrogen to glow red, creating this enormous, flattened donut of light that can be up to 400 kilometers wide. It's just wild. And get this, the discoveries just keep coming. Very recently, citizen scientists noticed this faint, kind of spooky green glow that was haunting the sky right after a sprite appeared. So, of course, they named them ghosts. And just last year, scientists figured out that green glow comes from excited oxygen, just like in some auroras, and tiny bits of iron and nickel dust left behind by meteors. How cool is that? So, okay, these fleeting lights are beautiful. They're mysterious. But why do scientists and citizen scientists spend all night chasing them? Why does any of this really matter?
Well, TLEs are basically a window into the incredibly complex electrical circuits of our planet's atmosphere. They can actually influence atmospheric chemistry and even give us new ways to understand our weather systems. And what's really amazing is the role that the public plays. Citizen scientists discovered ghosts, and now projects like NASA's Spritaculacular are actively inviting people from all over the world to share their observations.
So, to quickly recap our journey upward, this table gives you a fantastic side-by-side look. We started with those lower altitude blue jets, climbed up to the ghostly red sprites, and finished with the vast ultra-fast elves at the very edge of the atmosphere. And notice the pattern, right? The higher you go, the faster and more fleeting they become. Blank and you'll literally miss them. Let's end with another thought from Paul Smith, the person who started us on this journey. His obsession with capturing these things comes from a really simple, beautiful fact. Every single one is unique. They're like snowflakes, a fleeting, one-of-a-kind piece of natural art. And that leaves us with one final huge question. We know there are monster storms on planets like Jupiter. So if our own atmosphere is hiding these incredible fleeting wonders, what other kinds of sprites and jets and phantoms might be dancing completely unseen in the skies of distant worlds?